Welcome to our next video over empirical and molecular formula. Empirical and molecular formula are related to percent composition. In fact, in a minute when we go through the mathematical process of finding the empirical formula, we're going to use the percent composition in order to do it. So they're just the forward and backward operations of the same process. Okay, so what is an empirical formula? Well, it is the smallest whole number ratio of the different atoms within a compound. So, for example, if we had glucose, which hopefully you remember from photosynthesis in biology, and we wanted the smallest whole number ratio of all the different atoms in that compound, I can look here and see that we've got a 6, a 12, and another 6. These are all divisible by 2, but they're also all divisible by 6. I could take a 6 out of each one of those, and that would give me the smallest whole number ratio. If I did that, then I would end up with CH2O. So I've divided everything by 6, and that gives me the smallest whole number ratio. This is what we call a molecular formula. It's the actual formula for the molecule, and this is the empirical formula. Now, the empirical formula can be the same for multiple different compounds, and that's because they may share similar building blocks with each other. Okay, so let's get down to how we find the empirical formula for any molecule, not just for glucose. If you are given percentages, then you are to assume that you have a 100-gram sample. When you do that, it allows you to change all of the percentages into grams. So you're going to convert all grams to moles. Remember, if you're given percentages, then you just change those to grams and then convert to moles. Then step 2 is you're going to divide by the smallest number of moles. And then step 3, create whole number subscripts. And that just means if you get a decimal point, then you need to multiply everything so that it becomes a whole number. So that's what this chart down here is for. If, for example, after you divide by the smallest number of moles, you get an answer that has 0.5 in it, then you need to multiply everything by 2 so that this would change into a 1. That way you can get a whole number. The best way to think about this is to actually do a problem, and everything should make more sense that way. So here's an example question. In an unknown molecule, there's 4.15 grams of carbon and 1.38 grams of hydrogen. Determine the empirical formula for the substance. Okay, so step 1 was that we have to change all of the grams into moles. So that means we're going to divide each element by their atomic mass, and that will give us the moles. Let's do that real quick. I realized I was going to need some more room, so I had to move step 2 down. Alright, so we have converted each of the grams of carbon and hydrogen into moles of carbon and hydrogen. Okay, now let's look at step 2. Step 2 says that we divide the number of moles, that's these right here, by the smallest number of moles out of everything in order to determine what the ratio is of carbon to hydrogen. In other words, what their subscripts are. Okay, so looking at this number versus that number, we can see that carbon has the smallest number of moles. So we're going to divide everything by carbon's number of moles. Okay, when you divide a number by itself, you obviously get 1. And when we divide hydrogen's number of moles by carbon's number of moles, we get this number. Now, we were supposed to get a whole number, and as you can see, this is really close to 4. So what kind of our method is going to be is if we're within 0.1 of a whole number, we can just round it up. So since we have 3.9, we can round that to 4. If you're more than 0.1 away from a number, then you're going to need to multiply by those numbers in that chart. Okay? So what we just found out then, this 1 and this 4, those are actually going to be the subscripts for the elements that they came from. So when we're trying to build our empirical formula, we're going to say that we have 1 carbon, and we have 4 hydrogens. Okay, so this is the empirical formula. And I always just get in the habit of labeling that it's empirical because in the future you're going to have to figure out what the empirical formula is and what the molecular formula is. And so in order to not confuse yourself, if you're already in the habit of labeling, then you won't have any confusion later on, okay? And so that's it for empirical. You just, step 1, convert all of your grams into moles, divide by the smallest number of moles, make sure you get a whole number, and then build your formula with the elements and their subscripts. Okay, so let's do another one and we'll apply those same steps. Phenol is a general disinfectant. It's composed of carbon, hydrogen, and oxygen. Its composition is as follows: 76.57% carbon and 6.43% hydrogen. Determine its empirical formula. Okay, so we have a couple of things we need to notice about this problem setup. First of all, they gave us percentages. Remember, when they do that, we're going to assume that we have 100 grams of the sample to start with. The sample in this case would be phenol. And when we do assume that we have 100 grams, we're able to just go in and change those percentages into grams. Okay, the next thing we need to notice is they gave us carbon and they gave us hydrogen's percentage, but they said that phenol is made up of carbon, hydrogen, and oxygen. That means they didn't tell us information about oxygen, and we're going to need to know that. So how can we figure out what oxygen's percentage is? Okay, hopefully you understand that since we're assuming we have 100 grams to start with, we can just add these two together, subtract from 100, and that will tell us how much oxygen we have. Okay, so that gives us 17 grams of oxygen. Now we're going to do step 1, which is to convert all grams to moles, because we've already converted percentages into grams. Alright, so we have converted all of the grams into moles now, and now we're ready to do step 2. We're going to divide by the smallest number of moles. Alright, so obviously this is the smallest number of moles here, so we're going to divide each of these moles by this value right here. Okay, so anything divided by itself is obviously 1, and up here we get 5.9. Remember, I said if we're within 0.1 of a whole number, we can go ahead and round up. Okay, so these become 6's then. Now we're ready to create the actual formula. So this is the subscript that goes with this element. So let's build our empirical formula. So we have C6H6O as our empirical formula. Alright, so we've worked through 2 examples of that, and hopefully you are seeing it, you're getting the hang of it. Same steps every single time. Okay, so now let's talk about molecular formula. Again, molecular formulas represent the actual number of atoms in the real molecule, and a bunch of molecules can have the same empirical formula. For example, the sugars. We already talked about glucose, but there's actually a whole bunch of different kinds of sugars, and they usually end up having the same kind of empirical formula. That's the one we came up with earlier. So we have to determine what our molecular formula is so we can find out exactly which sugar we're talking about, or which other real-life molecule we're talking about. Okay, so here are the steps that we need to follow in order to come up with the molecular formula. Okay, first you have to be given the molar mass of the actual compound. They have to give that to you. Okay, the second thing is you need to know the molar mass of the empirical formula. So sometimes they may tell you what the empirical formula is and then you just calculate the molar mass of it. Other times you may have to come up with the empirical formula yourself and then calculate the molar mass of it. And we just do that by breaking it down, and we're used to that by now. Then you're going to take the molar mass of the actual compound and divide it by the molar mass of the empirical formula. And when you do that, you're going to get a multiplying number. Okay? Now, for this one out here, in your notes, I want you to write big over small. because it's always going to be the big number over the small number. Okay? Now that multiplying number that I was talking about, you're going to apply it to the empirical formula. So you're going to take the empirical formula and multiply it by whatever number you get here, and that will give you the molecular formula. Alright, so let's go through that and see if we can apply these steps. Okay, so here's an example question. The empirical formula for hydroquinone, a chemical used in photography, is C3H3O, and its molecular weight is 110 grams per mole. What is its molecular formula? Okay, so they were nice to us in this question, and they told us what the empirical formula was, so we don't have to do that ourselves, thank goodness. And then they told us what the molar mass of the actual compound is. They have to do that, okay? So that's step one, always taken care of for you. Step two, calculate the molar mass of the empirical formula. That's this right here, so we need to break it down. I've broken it down in other videos, so I'm not going to type all of that out for you. I'm just going to show what the molar mass for that compound is. Okay, so we have 55 grams per mole here for the empirical formula. Okay, the next step is to divide the big number by the small number. Okay, in other words, the molar mass of the actual compound divided by the molar mass of the empirical formula. So we're going to do 110 divided by 55. Okay, so we do 110 divided by 55 and we get 2. This is that multiplying number. So we're going to multiply our empirical formula by this number here. Okay, so when we do that, you get C6H6O2. That is our molecular formula. Okay? Alright, let's do another practice question. Naphthalene is a carbon and hydrogen containing compound, often used in mothballs. The empirical formula is C5H4, and its molar mass is 128.16 grams per mole. Find the molecular formula. Okay, so again, they gave us the empirical formula. Awesome. They gave us the molar mass of the real compound, which they have to do, and now all we have to do is the rest of the steps. Put a picture in here for you of mothballs. I got this picture off of eBay. Usually they come in a box, but this one had naphthalene written across it real big, so I wanted you to be able to see that. Alright, that's just there for fun. Let's get down to work and actually come up with the molecular formula for it. The first thing we need to do is find the molar mass of our empirical formula, which we can do by breaking it down. Okay, so here is the molar mass of our empirical formula, and now we are ready to do step 3, which is to divide the molar mass of the actual compound by the molar mass of the empirical formula. Again, big divided by small. Okay, so we end up with 1.98, and again, remember, if you're within 0.1 of a whole number, you can go ahead and round up, so we get 2 here. That means we're going to multiply the empirical formula up here by 2 in order to get our new molecular formula. That's our last step. Okay, so let's do one more. Alright, last question. A compound with the following composition has a molar mass of 60.10 grams per mole. 39.37% carbon, 13.41% hydrogen, and 46.62% nitrogen. Find the molecular formula. Okay, a couple of things. First off, they gave us percentages, which means we need to convert those to grams. That's easy. We just replace the percent symbol with grams. Okay, the next thing that we need to understand is, since they gave us those percentages, that means that we have to figure out what the empirical formula is for ourselves. They did not give it to us this time. So we'll go through the process of getting the empirical formula, and then we'll get to the actual question to find the molecular formula. Alright, we've converted all of the grams to moles, and now we're going to divide by the smallest number of moles. So obviously the 13 is out, and carbon is 3.3, nitrogen's 3.3, the third one's a 2, the third one's a 2, the fourth one's a 7, the fourth one's an 8. So carbon wins out as the smallest number of moles. So we're going to divide everything by this value right here. Okay, so here's what we get. We have 3.99 here. Again, remember, if you're within 0.1 of a whole number, you can just round it up. Alright, remember, these numbers represent subscripts from the element that they came from. So let's build our empirical formula. Alright, so we have CH4N. But remember, that's not actually what they asked me for. They asked me for the molecular formula. So they have to give me the molar mass of the actual compound, which they did right here, and then we need to come up with the molar mass of the empirical formula. How do we do that? By breaking it down. Alright, so we've broken down our empirical formula and come up with the molar mass for it. Then the next step is to divide the molar mass of the actual compound by the molar mass of our empirical formula. Remember, big over small. Okay, so when we do that, we come up with 2 as our multiplying number. So we're going to multiply our empirical formula here by 2 to get our molecular formula. Alright, so we get C2H8N2 as our molecular formula. Okay, so that covers it. We've gone through empirical formula and molecular formula, just doing the same steps every single time and revisiting some old topics like breaking down a molecule to find its molar mass. If you have any questions about this, please come see me for tutorials, and as always, thank you for learning with me today. Bye!